Hello friends, today we are going to learn an identity. But before that, we must know about this lady right here. Her name is Sophie Germain. She was one of the greatest mathematician, a female mathematician. She broke the so-called rumor that only men can be good mathematicians. So sisters, she is a inspiration for you all. Now she is not just a mathematician, she is a representative of feminism, a true feminism. She attempted to prove the Fermat's last theorem uh, in the 18th century, and while doing this, she came across some very beautiful identities, some of which are used in solving Olympiad problems. One such identity on her name is the Sophie Germain identity. Now, this identity states that any number of the form a raised to fourth power times 4 raised 4 times another number raised to fourth power. Any number, if a number is, if a number, let's say k is of this form, k can never be prime. If a comma b greater than 1, uh, uh, one of them must be greater than 1. Or if both are, then also it can't be prime, because if both of them are prime, 1, then the number is 5, which is a prime, so both of them must be greater than. Now this identity is never prime. This is proved very elegantly, and she proved this, the lady to the left of the screen. Now what we do to prove this is we add and subtract 4a square b square from the given identity, so that we get something like a square plus 2b square whole square minus 2ab whole square. I wrote this for a square b square as 2ab whole square. Now this is a square minus b squares. We can clearly write this as, so it can be easily seen that this is, this can always be factored into two numbers. Now, why was I telling that the A and B can't be one? Because if suppose A and B both are 1, this becomes 1 plus 1 minus 1 minus 2, that is 1. This factors become 1, and this 1 plus 2 plus 2 is 5. So this is the prime. That's why I told except, I mean, one of them must be greater than 1 or greater than 1. Now, let's see some application of this identity. Let's start with a question. It's a simple one. I will leave you with some tougher problems at the end, because if I do the tougher problems, you would lose a good problem. So it's better to learn any concept with a simpler problem and apply that in a much higher level problem, so that it builds your intuition and mathematics skill. Now let's suppose we are given to prove that 2 to the power 44 plus 7 to the power 36 uh, times, wait, let me write this as 36 times 4 is never a prime. So one way to prove this is we can take the 4 out of here. So Now, what if the question was 3 to the power 44 plus 7 to the power 36 times 4? What we if we needed to prove this thing is never a prime. Ma'am Sophie Germain comes in to rescue here. So what we'll do is we will write this 3 to the power 44 as plus 4 times. Now this assumes this form, and by Sophie German identity we can uh, do some engineering to reach some, like we will subtract and add as the A and B's here to prove at the end that this may never be a prime. So this way we can take help of this Sophie Germain identities. Now I will leave you with some problems. So here are some problems for you. Now these are friends. I will be leaving you with some problems on Sophie Germain identity. I hope you will find them enjoying. Now these are some of the problems. Now the first one is proof based. Those who don't know how to write proofs may skip this question. This question is from Hungary, competition in Hungary. This also appeared in RMO exam of India and ISI entrance exam B first paper 22 of 2006. Problem number 3 of the subjective paper, and but it first appeared in Hungary competition there in 1977. Now this is a theoretic one. I hope you can prove that. In RMO they just changed this thing. They wrote n greater than 1. N greater than 1 directly implies